The topic is sampling distribution of sample mean x bar. The definition says the sample means x bar have a normal sampling distribution with normal equal the mean of the population and standard deviation equal to the standard deviation of the population over square root of n, which is size of the sample, provided the following conditions are met. A, the samples are drawn randomly, in other words, the randomization. For B, N, the sample size has to be bigger or equal than 30. And then C, the population standard deviation has to be a number, finite. So it's a real number. So let's do this example. A grocery store's receipts show that Sunday customer purchases have a skewed distribution with a mean of $32 and standard deviation of $28. So remember, X represents what? X is represent the random variable is Sunday customer purchases. And of course it's in dollars. It says have a skewed distribution with a mean $32 and standard deviation $20. So we know that mu is $32. We know the standard deviation is $20. And it says explain why you cannot determine the probability that the next Sunday customer will spend at least $40. In other words, why we cannot estimate P of X bigger or equal than 40. Why we cannot find this value. Of course, because it's not normal. So it says here skewed. Skewed means this is how it's gonna look like. So we cannot use the normal approximation. So what we say here, this is distribution of X. Distribution, oops, it's supposed to be here. Distribution of X is skewed, which means cannot approximate using normal model. So for B, can you estimate the probability that the next 10 Sundays customers will spend an average of at least $40? Now, this is distribution of X bar. It can be normal. However, for it to be normal, we want N. We want the randomization, which is okay. We can even assume it. But we want N to be, which is in this case 10 Sundays, which is 10. We want this to be bigger or equal than 30. It's not. So it's less than 30, which means no. The requirement, the conditions that we have here are not met. So no. Now question C, is it likely that the next 50 Sunday customers will spend an average of at least $40? Now here we don't have a problem because we know the distribution of X bar is normal. Why? I mean, we can assume SRS, the randomization, right? N is equal what? 50. We don't have a problem because it's bigger or equal than 30. And then we know that the standard deviation is equal to $20, which is a finite number. So the answer will be yes. So let's find, so they're asking us to find the probability of X bar to be bigger or equal than 40. Remember, the same question was here. Find the probability of x bar bigger or equal than 40. But here we could not do it. Could not. So we're looking for, so assume the $40 is here. So we're looking for this area bigger than 40. I'm going to go all the way to 1,000. Because 1,000 is bigger than 4 standard deviation. Any number huge will work. And let's use a normal CDF. So that would be the normal CDF. The lower bound we said 40. The upper bound 1,000. You can pick 3,000, any number that's huge. And then the standard deviation, well, we need to calculate that one. Well, we didn't calculate it, so let's calculate it here. We know that the mean of x bar is equal the mean of the population, which is $32, and the standard deviation of x bar is equal to the standard of the deviation of the population divided by square root of n, which is 20 divided by square root of, what is that, 50. And if you use the calculator, suppose you get $2.83. 2.83. So the mean is 32 and the standard deviation is 2.83. Let's use the calculator. Suppose to get 0.0023, which is 0.23%. So that's the likelihood. And that's it for this example.